Okay, now in this question number 8, the ball strikes the horizontal surface with the momentum P at the angle theta to the surface as shown. The ball rebounds with the same magnitude of the momentum at the angle theta to the surface. The ball is in contact with the surface for time t. What is the magnitude of the average resultant force acting on the ball? Look, this is the initial momentum, this P. It has two components because the momentum is a vector. So this is Px component, but negative. And this is Py. Left side, the X component is negative, and vertically up, the Y component is positive. Now, after collision, this momentum P, it has two components. This is Px, it's positive, right side X positive, and vertically up, this is also positive. Now, this momentum is positive, this momentum is negative, so the horizontally, the momentum becomes 0. Both are cancelled. Now, vertically, two components. So the total vertical component will be Py plus Py, total, this total vertical component. So the total vertical component will be Py plus Py, 2Py, but Py is P sine theta, so 2P sine theta. Now, at the bottom, there is no momentum. So the change of the momentum in the vertical direction will be 2P sine theta minus 0. Mean change of the momentum is 2P sine theta. And then, according to Newton's second law, rate of change of momentum is force. So F is equal to change of momentum divided by time. So it is 2P sine theta divided by T. This is the force. So the answer is D. Okay, in this question 13, the mass of 30 kilogram is suspended from the end of the wire. The horizontal force F acts on the mass so that it is in equilibrium with the wire at the angle of 30 degrees to the vertical. What is the magnitude of the force? Look, it is equilibrium. So three forces are acting. One is the F, other is the tension, and the third is the weight. So this is the weight. And this is the horizontal force F. And this is the tension in the string. Resultant force is 0 because the equilibrium, this angle is this. So it's a right angle triangle. Now F is required and we can calculate weight from this mass. So we can write F divided by W, mean perpendicular divided by base tan theta. So F is equal to W tan theta. And then this F is equal to W is mg, 30 times 9.81 multiplied by tan of 30 degree. So the after calculation, this answer is coming 169.91 Newton. So it is 170 Newton. Okay, now in this question number 18, an aircraft travels at the constant velocity of 90 meters per second in the horizontal flight. The diagram shows the horizontal forces acting on the aircraft. This drag force is given, the mass of the aircraft given. What is the power produced by the thrust? So thrust is acting forward, but due to the constant velocity, the resultant force is 0. Mean the thrust and the drag force both are equal. So this thrust is also 2400 Newton. Now power required. So the power is equal to force multiplied by speed, because the power formula is work divided by time. Work is F into D. So divided by T, This d divided by t is speed. So power is force into speed. So the force of the thrust is 2400 and the speed velocity is 90. So after calculation, 2400 times 90, answer is coming B.